Station, this is Houston. Are you ready for the event?
Houston, we are ready.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
And we hear you loud and clear.
Great. Please stand by for opening remarks.
Welcome to La Mesa Junior High School. I'm Mike Coleman, the superintendent of the Hart District, and I think you'll agree that on days like today, our future is truly bright. I'm here to introduce a group of curious students from throughout our district who will ask questions directly with astronauts aboard the International Space Station. So let's get started.
My name is Jevin, and I'm from La Mesa Junior High School, and my question is, what is the best experience you had in space so far?
There's a lot of good moments on the space station. I think just getting there was absolutely unbelievable. I remember my first time, even the second time, it doesn't get old. You enter the station. First of all, you see it coming when you approach with your spacecraft after launch, a lot of emotions. And then you dock, you open the hatch, you see your friends and your colleagues that have launched a little bit earlier than you, and that you meet up with them on board the space station. It's a fantastic time. Everybody's happy, lots of smiles all around, and that's a really, really good time. That's my best moment so far, I guess.
My name is Ava, and I'm from Castaic High School. My question is about the fresh food analysis projects being conducted on the station. Do you believe that in the future you'll be able to prepare your own meals through food grown in space?
That's a great question, Ava. I really like to prepare food on the ground using fresh vegetables and fruits, so that would be something that I would enjoy. We have grown small crops in space before, and one of my crewmates, Shane, was able to grow and eat lettuce up here last time he was up here. Right now we're growing hatch chili peppers, which we're excited about, but they do take a long time to grow. They have a more complicated system. They take longer to germinate and longer to grow and produce fruit, and so we're hoping to see some chili peppers before we go home, which would be great. Because they're tasty, but also because in successfully growing these more complicated plants, we're learning more about how to do this for the future. So I think in the future, people will be able to use more fresh foods to supplement the food that they eat in space, but we're probably a long way from being able to completely prepare our foods from scratch in space.
My name is Sochi, and I'm from Rio Norte Junior High School. What is a problem that has arisen during your time on the space station, and how long did it take to solve?
It's space. It's not always easy. So sometimes there's problems. It's part of the journey. It's part of what we're trying to overcome up here. It's not easy. Otherwise, it wouldn't take that much effort to do it. But so we've had lots of small problems. We haven't had a real big problem. We've been pretty safe. Spaceflight has been pretty safe for a long time, thanks to everybody's efforts. I remember we had so during a spacewalk recently, we had some hardware was not cooperating, and Shane has lost his helmet lights that disconnected from the helmet, and we had to improvise, a fix out there with what we have in a spacesuit. That was not easy. So that's one of the small problems, or sometimes a little bit bigger problems that we have to overcome. But we get a lot of help. We try to react as a team up here, and also as a team with all the mission controls on the ground. They provide us with a lot of help, a lot of advice, and more often than not, they solve the problem for us.
My name is Chloe, and I'm from Golden Valley High School. My question is, how do you orient yourself in space with so little gravity? Do you have this side up signs on the station like on a box?
This side up signs might be really helpful, especially when you're newly arrived to space station and you're getting used to and having fun with sort of zooming around from module to module and spinning, corkscrewing as you go. And you might get into an area and think, where the heck am I? Which way is up? But in fact, you can work in any environment. It doesn't feel any different whether we're upside down, or if I come up here, it doesn't feel any different to me to be working up here than it does when I'm up sort of upright in this orientation. When we train on Earth, we do train like this. So feet towards what we call the deck and head up towards the overhead. And we can tell where that is based on where the lights are. So the lights are at up towards the overhead, and the air intakes are down towards our feet. So that if you really need to be oriented on which way is up, that's how we do it.
Hi, my name is Abigail and I'm from Saugus High School. My question for you is artificial gravity a feasible achievement, and if so, how would it affect the three-dimensional life on board the space station?
It's a great question. So I think it's fair to say that it's not achievable right now, because you would need to rotate either the entire spacecraft or huge big parts of the spacecraft like a module. So mechanically that would be very, very complicated. We're not doing this right now. For now, we rely on countermeasures. So we do exercise every day to not lose too much bone mass and muscle mass, because that comes with not having to support your weight and support and just use your body as you would on Earth. So that's what we're doing right now. In the future, certainly not. Nothing's impossible. All the stuff that was science fiction 50 years ago or 100 years ago has become true, most of it today. So who knows? Maybe one day it will be. But for now, there's been studies, how to centrifuge a module, part of a module. But right now, we're not using them. Maybe one day.
My name is Evan. I'm from Valencia High School, and I'm curious about cool flames. I want to know how they work and how these experiments will continue, and also how they'll be applied into technology in the future.
Thanks for the question, Evan. Cool flames are really interesting, as I've been learning about them as well. And so cool flames that's a relative term. Cool flames actually burn around 600 degrees Celsius. And if you think about a regular candle that you might have in your house, that's at 1400 degrees Celsius. So they're cooler than a normal flame, but still reasonably hot. One of the things that's really interesting about them is that they were kind of discovered as a byproduct from another experiment, meaning somebody set up an experiment and was not expecting this to happen, but it was a result. And so I find that fascinating, that as we're conducting science experiments, that we learn things that we didn't even know to ask about, and so then we can ask a whole new set of questions. I find that fascinating, and that's what's going on with cool flames. And so new things are being discovered about the chemistry of combustion kind of all the time. There was a big discovery just this summer where the cool flames were capable with gaseous fuels for the first time rather than liquid fuels. And so that discovery about the chemistry of combustion is ongoing, and I think it will ultimately contribute to cleaner burning internal combustion engines on Earth, which of course would be fantastic.
My name is Sawyer, and I'm from Rancho Pico Junior High School. And my question is, on average, astronauts lose approximately 1% to 2% of bone mass each month in space. What methods is NASA using to try and stop bone loss on long missions?
Yeah, it's actually true. You get your facts right, and I think the two methods that we're using is, first of all, nutrition. You want to get all the good nutrients that you need, calcium for your bones, not to lose too much mass or density. So that's one thing we pay attention to. We try to pay attention to what we eat, just like we do on Earth, but maybe a little bit more on the space station. And the second is really just exercise. I mean, I say just exercise, but it's not easy to exercise on the space station. You need a three-dimensional machine that's isolated in vibration from the rest of the station. You don't want to shake the entire station. That wouldn't be good for the scientific experiments. So we have that, and we have a bike, we have a treadmill. But it took a lot of engineering to make those things work, and they work really well. We use them every day. So that's what we do to try to counteract bone loss, and we've been really successful. I think long-duration missions at the very beginning on the Mir space station, you were talking about more than 10% of bone loss, and now we're closer to 1%, which is I would say almost zero as far as I'm concerned. So we're doing good. We'll keep doing that in the future, and there's also research in some other ways to mitigate bone loss. But for now, those two methods are the ones we use every day.
My name is Zachary, and I'm from Hart High School. I'd like to know what raw materials could be found on the moon, and how might they be harvested?
So that's a really interesting question as well. And so when we think about what raw materials we would get on the moon, we think about directly how might those materials help us to exist on the moon. And so I think about solar power. We can use solar energy on the moon. I think about oxygen, getting oxygen from the materials on the moon, and various kinds of metals are available. And then also covering the whole surface of the moon is debris that we call regolith. And actually right now on the International Space Station, just right over here in this module, there's a a 3D printer. An experiment has just started to use a simulated regolith to see, can we make building materials, something that we could make a habitat on the moon out of regolith. And so those are the materials that we might use in the short term when we're initially starting a habitat on the moon. And then that enables us to not have to launch so much stuff from the Earth, to be able to stay on the moon and learn more about what's available on the moon.
Hi, my name is Sophia and I'm from Santa Clarita Junior High School. How far into outer space can we travel with the Gateway being the starting point?
That's a great question. So I think first of all, the Gateway, what it gives us is really access to the moon, and the moon is 400,000 kilometers away from the Earth, roughly. So that's 1,000 times further into space than we are right now on the International Space Station. So it's no small feat. And with the Gateway, you can access all the surface of the moon, which is also very, very important for us when we want to go back and establish a more sustained human presence on the moon. But I think the Gateway is also a fantastic starting point for any venture further and deeper into the universe, including our next target, which is going to be Mars. We have Mars in the line of sight. All the agencies agree on it. That's the goal. That's the end game, and that's what we're working towards. Of course, the moon is important, but we also have Mars in sight, and the Gateway is going to enable access to both of those targets in the near future, and that's pretty fantastic.
Hi there. My name is Oliver, and I'm a student from Academy at the Canyons. And my question is, understanding the magnitude of the work you do, how do you think your own confidence or stress in that work would be affected by being in a lunar environment? Thank you very much.
That's a really interesting question, and it's not one that I've thought a lot about before. But I think that the environment in a lot of ways will be similar. So you're going to have to live in a confined habitat. You're going to have to recycle your air and your water. You're going to be eating shelf-stable food with maybe some fresh food on the side. If you want to leave your habitat, you're going to have to use specialized equipment and procedures, just like we do here on the International Space Station. So in a lot of ways, very similar. And even though there'll be a small amount of G, you'll still have to be doing exercises to maintain your muscle and bone mass. And so I think because it's going to be quite similar in those ways, that I think your mental preparation and the training that you do on Earth will be quite similar. The biggest difference, as Thomas alluded to earlier, is going to be how much farther away you are. So you're a longer trip away from home. It would take probably 3 days to get home rather than maybe less than 1 day, which we can do up here. So that mental awareness of that, and I think probably the crew would have to be ready to be a little bit more autonomous. We rely very heavily on the ground, obviously, running this spacecraft, and we work together as a team, and I think we would continue to work together as a team, but the crew would have to be able to respond a little bit more independently in certain circumstances, and so that might require a little bit of a different kind of mental preparation.
Hi, my name is Fionn and I'm from Canyon High School. The educational requirements to become an Artemis generation astronaut are clearly outlined on NASA's website, but what are some of the personal qualities that are most important in being selected?
Wow, there's a lot of traits, and I think there's a lot of ways to answer that question. But I would say being a team player, being somebody who's easy to work with, patient in a way, who can be a leader but also a follower, who can adapt to the circumstances, because 6 months on the space station, you're going to have to adapt. You cannot have things your way all the time. You cannot do things always exactly the same. You have to be a team player. You're not going to choose the people you go to space with, because that's how it is. So you have to be able to work with a lot of different people. So obviously you need dedication, you need things like this, but to me, kind of the most important trait or aspect of personality is to be a team player, somebody who's easy to work with and to live with, because the station is a workplace, but it's also a living place. We've been living like a little family for a few months now, so you have to be somebody who's easy to get along with.
My name is Omar and I'm from Sierra Vista Junior High School. Can you elaborate on how the exploration of the moon will help future Mars missions, knowing that Mars is so much further away and the conditions are different from those on the moon?
That's a great question, Omar. I think of the moon kind of like I think of the space station as a stepping stone towards our further goals. And so here on the space station, we are already conducting technology demonstrations in water purification systems, air purification systems, those kinds of things that will enable our stay on the moon. And so similarly, the things that we learn to enable our habitation on the moon is going to enable us on Mars. So we're going to develop technologies, we're going to develop hardware, we're going to develop procedures that help us to live sustainably on the moon, and that's a little bit closer. We talked about, the space station is maybe less than a day away from Earth. The moon is 3 days, and Mars is probably like 6 months. And so it's good to be able to have a test bed, basically, to test out your different equipment and procedures before you go farther and farther away.
My name is Maddie. I'm a student at Arroyo Seco Junior High School. I was wondering, what is one of the largest obstacles that NASA faces in trying to sustain life on Mars?
There's a lot of obstacles. One of them, I think, is radiation. You'll be exposed when you travel further, deeper into space, and when you get further away from the protection that the Earth's magnetosphere is giving you, you get exposed to more radiation. So a little bit our case, we get maybe 100 times, 200 times more than average on the ground, but it's still pretty low. If you go into deep space, if you go to Mars, if you travel for extended periods of time, then it's going to be much more than this, and we have to find a different way to protect ourselves. And so if you're going to spend a lot of time on the surface of Mars, you'll have to shield yourself. So maybe dig your habitat underground, or maybe have some very thick walls and find ways like that to protect human beings and living beings from radiation. That's one of the problems. In living confined for an extended period of time, a lack of gravity or reduced gravity, smaller amount of gravity as we have on Earth. All those are challenges that we're going to have to solve, that we're working towards solving, and there's a lot of advances in all those topics, being made every day in the space agencies.
My name is Rakaya, and I'm from La Mesa Junior High School. My question is, would the water on Mars be safe to plant our crops with?
So I think a benefit to humanity comes from the fact that human beings we're explorers, right? We're seekers. We're very curious. We have always been kind of pushing the boundaries of what we understand, what we know, and we're always seeking, looking over, trying, climb the hill to see what's on the other side, kind of thing. And so I think we have this drive, and we continue to have this drive. And the benefit to us when we set these challenges for ourselves and meet these goals is that along the way, in order to meet these challenges, is we have to develop technologies to help us do these amazing things that we want to do. So, for example, in going to the moon, we had to develop solar cells, or technologies that eventually led to solar cells like we have today. Water purification systems, again, air purification systems, even CAT scans that we use for medical diagnoses on Earth come from technologies that were developed to get us safely to the moon. So we don't always know exactly what the individual benefits are going to be, but I know that as humanity strives to meet these big challenges, we are going to come up with solutions that lead to technologies that benefit our everyday life.
My name is Jonathan, and I'm from West Range High School. How do the astronauts now play a pivotal role in the future exploration of Mars?
Great question. Like Megan was saying before, the space station we're really doing two things on the space station. That's how I see it. We're doing research for Earth. We're trying to find solutions for very earthly problems every day, but we're also doing research and technology innovation for space, for being able to going deeper and further into space. So there's a good chunk of the experiments that we're doing, of our daily activities, that are really targeted at learning more about human beings in a space environment, what it takes to keep people healthy and functional for extended periods of time, what it takes to go deeper into space, and also technology and also operations. How do you overcome the communication delays and things like that? So I would say there's a good third of our time, maybe quarter to a third of our time, that's really dedicated to learning how to get further and deeper into space. And the result of all those experiments is going to enable us to go to the moon and go to Mars. So we might not go in person, Megan or myself, but at least we'll know we have played a role in the return of humankind to the moon and the first steps on Mars, and that's going to be unbelievable to watch.
Thank you, NASA. Thank you, astronauts. This has been a truly incredible experience for the students at La Mesa Junior High and the Hart District. Students, your potential is as limitless as the universe. Your future will be out of this world.
And thank you for joining us today aboard the International Space Station. Stay curious and good luck.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all participants. Station, we are now resuming operational audio communications.